Alright, so what we are going to look at on part of today is solving special types of linear systems. Once again, if we do have our snow day, I would be looking at your quiz and figuring out how do I solve these equations. There's three methods: graphing, substitution, and elimination. This warm-up is our graphing one. So if you did poorly on this, pay close attention. When I graph these systems, these are two equations, which means I need to have two lines. I'm going to look at the first one. 3x plus 2y equals 10. So I'm going to go over here and I'm going to write that. 3x plus 2y equals 10. And since I'm graphing this, I need to set it equal to y. So I'm going to move everything over. Here, let's open up your notes so you can follow along, please. I'm going to subtract 3x from both sides of my equation. I'd have 2y equals negative 3x plus 10. That should have been no problem. We've done that a number of times. I now have to get y by itself. So I divide this by 2. And I would get y equals negative 3 divided by 2. I can leave it as a fraction. That's okay. And 10 divided by 2 is 5. Now that I have that, that is in slope-intercept form. My y-intercept, which is b, is 5. My slope is negative 3 over 2, which means go down 3, go right 2. To graph this, you always do your y-intercept first. So y-intercept is positive 5. There's my y-intercept. I now do my slope. Negative 3 over 2. So go down 3. So from my y-intercept, 1, 2, 3. And I go right 2. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. And now comes the part that I hate about this method, is I have to draw my line and I need to do it as straight as possible. Ooh, that was a 2. Well, yeah, it's going to come straight. I have to get through all my points. This is... There we go. All right. That's my first line. On the quiz, this is where I saw some people stop. And that's not possible. They try to combine the two things and make one line. No. I'm trying to solve what coordinate could go into both of these. So this is line 1. Now I'm going to solve for line 2. So this second line right here, if I show my work, I'm actually going to erase this stuff so I have room to work. Now I'm going to have 3x plus 2y equals 2. We do the same things. I minus 3x to get y by itself. And I have 2y equals negative 3x plus 2. Divide by 2. We get y equals negative 3 over 2x plus 1. Now in this one, my slope is still negative 3, 2. And my y-intercept is 1. So I graph this one. Y-intercept is 1. And I'm going to go down 3. 1, 2, 3 over 2. 1, 2, 3, 1, 2. 1, 2, 3 over, oops. Over 2, it's probably right about in here. If I graph this line, Good, you guys are starting to catch on to this part. Uh-oh, what did I do wrong? How come that's... Uh-oh, I think I did something wrong. I counted wrong, didn't I?
You did.
Yeah. This one should have been right in here. Oh, I lost my line. Oh, I'll just do this.
But you have to fix the other one too.
Devlin.
You have to fix all of them.
Oh, no. Now we're just having failure after failure.
You need to fix all of them.
Yeah.
This should be math class with comedy.
Oh, for crying out loud.
Comedy class. Do another research. That's the big eraser.
I'm going to redo my point because I made a mistake. Let's see. At 1, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. There we go.
I'm a big kid.
Now, what do we notice about the... No, because you're talking on the first equation, buddy. On the very first one, 3x plus 2y equals 10. When I did that one, 3x plus 2y, it's a good question. I like that you're asking. We subtracted our 3x, right? And we get 2y equals negative 3x plus 10. Now, when I divide by 2, y equals negative. Do you see a mistake? Okay. No, that's a good question. I just made a bunch of mistakes, so it's all good. All right. Now, let's pay attention to this. I spent more time on this because this is the one that we're having the most trouble with. Most people are struggling with the graphing, which is surprising to me. All I did was solve each one. Now, both of these equations, on this first one, the slope was negative 3/2. The y-intercept was 5. This one, the slope was negative 3/2. The y-intercept was 1. What do we notice about the two now? Brianna?
First of all, they're parallel.
Okay, the lines are parallel.
And that, I don't know what else.
Different notes. What else do we notice about this though? If you look at these both, look at their slope. Their slopes are the same. The rise and run is the exact same. The only difference is their starting points. If you ever have two lines that have the exact same slope, but they have a different y-intercept, they will be parallel. These will never cross. Well, our solution is, where do the 2 points cross? That's our answer. So if they never cross, our answer is what?
No solution.
We would say no solution. Then, did you have a question too, or are you answering the question? Good. Our answer is no solution. This is one of our special ones. If I have the same slope, different y-intercepts, we have no solutions. Okay? If we look at number 2, first thing, I have 2 equations, and I'm graphing. So, I would have to solve for y. I'm going to minus an x on both sides. I'd have negative 2y equals negative x minus 4. Divide by the negative 2. And so that would leave me with y equals 1/2 x, not minus 2.
Plus 2.
Negative 4 divided by negative 2 is a positive 2. So on this one, my slope is 1/2. Y-intercept is 2. We graph that. There's my y-intercept. Up 1 over 2. Up 1 over 2. Up 1 over 2. Okay, we do our second equation. Y equals 1/2 x plus 2. Oh, do I have anything to solve?
No, it's the exact same.
Okay. It slopes 1/2. It's 2, so it's still, the second line is the exact same. What do we say if the two lines are the exact same?
Infinite.
This one, infinite solutions. So we don't have just one answer. There's infinite amount of solutions. These are our special types of linear systems that we are working with. So, if we look here, solve special types of linear systems. So far, we've worked with linear systems with exactly one solution. There are two other possibilities. So the one solution is when there's two lines that cross, and it gives us one answer. If we have no solution, that means our lines are parallel, and they never cross. And then if we say our lines coincide, we say infinite many solutions, or just infinite solutions. And that means that our line was the exact same line. You've already graphed this one in number 1, so we've done this one with graphing. So let's see how it works with substitution, or elimination. I'm sorry, I can't read. So we got to learn now when we use elimination, how do we understand when we eliminate something that we have no solution? Because we already know this answer is no solution. If I graphed it, they're parallel, we know the answer. But let's see what it does when we eliminate them. Well, when I look at this, I see 3x, 3x. I have the same coefficient. They're in the same order. X, y equals constants. So, me personally, I would times the 1 by -1, so I can just add them. So I'm going to do -3. I'm going to say negative, negative, negative. Now we can just go through that. So 3x minus 3x gives me 0. Those cancel out. 2y minus 2y, 0. 10 minus 2 is 8. All right, now look at our answer. We don't have a variable in it, and we just have a statement. 0 equals 8. Does 0 equal 8?
No.
Since that is false, since that does not work, you say no solution. This is what's going to happen when you use substitution or elimination. You will somehow eliminate your variables, and you'll get a statement. So what do you think infinite many solutions would happen? If this would have came out to 8 equals 8, then I would be like, oh, well, that's true. I have no variable. 8 equals 8. True, infinite many solutions. I know they're the same line. Okay, question? Right after we finish all this. Okay. So this one had no solutions. This was number 2. Let's look at what it looks like. And they want us to use substitution. This is a good method if you guys are still struggling. Make sure you're following along so you understand this. I'm substituting because I see that y is the same. It equals 1/2 plus 2. So here is y in this first equation. I'm going to rewrite it. X minus 2. And instead of writing y, I'm saying 1/2 x plus 2. Finish my equation equals -4. We solve. I have x, and now I'm going to multiply by a -2. -2 times 1/2 is -1x, so just -x. -2 times 2 is -4 equals -4. Well, right here, negative x minus x is 0. They cross each other out. -4 equals -4. Is that true?
Yeah.
We have no variables. We only have values and yes. True. Infinite. Many solutions. Now, I will show you one extra step because for some reason I always have people do this. They get to -4 equals -4 and they don't stop. And they go, okay, well, I need to add 4.
It's going to equal 0.
Then you get to it. 0 equals 0. That's also a true statement. Still infinite. So, we're going back to this. Lines intersect, you get one solution. When you solve, you will get x equals something, and you will get y equals something. Lines are parallel. If you do elimination or substitution, you will get a false statement, such as 0 equals 5. For infinite many solutions, you will get something that's a true statement, like 5 equals 5. Okay? So that's going to be the difference. Today, while you do your homework, if you're solving and you get it where the x and the y are eliminated and you get just the statement, 5 equals 8. It's false, no solution. That's how you knew if you graph the two, you get two parallel lines. If I get 12 equals 12, it's true. Infinite many solutions. I would get one line. Same slope, same y-intercept. If I come out and I get x equals 5, y equals 7, that's my answer. 5, 7, one solution. So, I'm going to come scroll down real quick because of what we're looking at. I'll have us do a couple practices, but I want to make sure we hit this up. We just talked about this. Lines intersect, one solution. Lines parallel, no solutions. Lines coincide, means they're the same line. There's infinite many solutions. So what do we know about the lines on here? These have to have different slopes. So when we have lines intersect, we have different slopes. Can we have the same y-intercept? Yeah, because that might be where they cross. The y-intercept might be different. They might cross somewhere else. Here, they had different y-intercept, so they crossed here. If the lines would have crossed here, they would have had the same y-intercept. Over here, the slope will be the same. The y-intercept is different. Lines coinciding. The slope is the same. The y-intercept is the same. This is a good graph for me. Lines intersect, one solution, different slopes, y-intercept same or different. Just exactly what we went through. I would be focusing on this. Okay? So, let's see if you guys can do this homework or an example before I give us our assignment. So, tell whether the line has no solution or infinite. When I look at this one, and do you want to graph it, substitute, or eliminate? Okay, let's try eliminating. They're both set up with x's, y's equals constants. Do they have the same coefficient for x or y? No. So let's change one. Which one should we change? Caitlin?
The top one, because we should times it by 3.
So which coefficient are you trying, or which coefficient to the variable are we trying to do?
I'm trying to
The y matches? Okay. So if everyone listens, Caitlin knows what she's talking about and she's doing this right. So make sure you're following along. She said, my y's do not match and I want them to. This is a 2, that's a 6. I'm going to go to a 6. This one will stay the same. So 3x minus 6y equals 30. However, this one is going to have to change. So I'm going to times this whole equation by what? 3. Because 2 has to get to 6, we times by 3. 3 times negative 2 is 3 times 2y is
6.
3 times negative 16.
Negative 48.
Oh, God. You guys are right. I did it times 2. I was like, ooh, you're way off. Okay. And now I look at my y's. Positive 6y, negative 6y. Because they are opposite, we can add. Negative 6x plus 3x is negative 3x. These cancel out. Negative 48 plus 30 is negative 18. Let's divide by negative 3. X equals 6. Okay. So far, I'm thinking we're going to have one solution. Because I got x equals 6. We have to solve for y. How do I solve for y? Aiden? Good. 6 in for x. So I'm going to do where x is a positive. So I'm going to say 3 times 6 minus 6y equals 30. You just go to any one of your equations and you substitute the x in. Okay, so that's 18 minus 6y equals 30. I need a minus 18. Those cancel out. Negative 6y equals 12. Divide by negative 6. Y equals negative 2. So what's my answer? My final answer? -2. This one had one solution. It was a normal one we were solving. Let's try this. Let's stop there. Here's why. I want you guys to have time to look over your quiz. So here's what I want you to do. I will record this. I'll go through today, and I'll do the rest of these examples for you, and I'll put them up on our video. So when you're doing your homework, or if we do not have school tomorrow, you should be able to go through here and finish your homework. Look at my examples to help you. Your homework. Following along. Your homework is lesson 7.5. There's 12 questions. You will need another piece of paper to show some of your work. Okay?